Let us learn about definite integrals. Integral a to b f of x dx is called definite integral. This a is called the lower limit and b is called the upper limit. This definite integral has a unique value. The geometrical meaning of definite integral is it represents the area under this curve f of x. For example, this is the curve y is equal to f of x, say. The lower limit is x is equal to a because integration is done with respect to x variable. So this is x is equal to a limit and x is equal to b limit is this. And with respect to x-axis, integration is done. So it is bounded by x-axis. So these are the four boundaries of this area. One of the boundaries is x is equal to a line. The other boundary is x is equal to b line. And third one is the curve f of x, y is equal to f of x, and x-axis. These are the four boundaries of that area. So the answer for this definite integral gives this shaded region, area of this shaded region. This is the geometrical meaning of a definite integral. To solve definite integral questions, we have two methods. Method one is using limit of sums. The other method is using fundamental theorem of calculus. Only when the question says by limit of sums, we use limit of sums method. Otherwise, we do direct integration and substitute the limit values. That is using fundamental theorem of calculus method. Let us see the formula of limit of sums method. Consider the graph of y is equal to f of x, which is a continuous function, say, in the interval a to b. Now we are going to find the area under this curve bounded by x-axis. So to find this area, we are going to consider rectangles and we are going to sum up all these rectangular areas. This is the width of the rectangle. Let us take the width as h. If I take h as a very large quantity, I cannot consider this as a rectangle because the upper boundary is a curve. It looks like this. I cannot take this as a rectangle. If I consider this as the length of the rectangle, I will get this area. Whereas if I take this as the height of the rectangle or length of the rectangle, I will get this area. In both the cases, I don't get the exact area. So what I am going to do is, I will write h tending to 0. If I take h as a very, very small quantity, almost equal to 0, that strip becomes a very thin, like a line it is. So in that case, I can consider that as a rectangle. By summing up all these rectangular areas when h is tending to 0, then I get area under the curve bounded by x-axis. For example, I am taking n number of rectangles, say. So what is the relation between n and h? This gap is, this length is b minus a. So h will be b minus a by n, where n is the number of rectangles and h is the width of each rectangle. So nh will be b minus a. As h tends to 0, n tends to infinity. Infinite number of rectangles will be there. So as h tends to 0, the strips, the rectangles are becoming narrower. Otherwise, the strips are not rectangles. Let us add all these rectangular areas to get area under the curve. So area of the first rectangle, for our convenience, we are going to take this length as the height of the rectangle or length of the rectangle. So area of the first rectangle is h into y coordinate of this point. When x is a, the y coordinate is f of a, plus area of the second rectangle, this rectangle. Width is again h, but height will be f of a plus h. This x coordinate is a plus h. So x coordinate for this point is a plus h. Corresponding y coordinate will be f of a plus h. Plus for the third strip it will be h into the length of the rectangle will be a plus 2h, etc. For the last rectangle, nth rectangle, for this last rectangle we are considering this height. Therefore, it will be h into f of a plus n minus 1 times h. Whereas if you consider this height, it will be nh. But in all the strips, we have taken the left-hand side height. Therefore, it will be a plus n minus 1 h. So, we can consider them as rectangles only when h tends to 0. So, this gives area under the curve, and it is denoted by the definite integral a to b f of x dx. H is common, we can take h out. Therefore, limit of sums formula is limit h tending to 0 of h into f of a plus f of a plus h plus etc. The last term will be f of a plus n minus 1 times h, where nh is b minus a. This formula can be written in terms of n. In that case, limit n tending to infinity we have to write. And h is b minus a by n we know, times f of a plus f of a plus h, etc. f of a plus n minus 1 times h, where n is b minus a by h. So we can do limit of sums questions using limit h tending to 0 using this formula, or we may use this formula. Write these formulae in your formula notebook and memorize them. We need to learn few sequences and series formulae. Let us write down those formulae. 1 plus 2 plus 3 plus up to n minus 1. In limit of sums question, the last term will have n minus 1. We know that sigma k, where k varies from 1 to n, the last term n is n into n plus 1 by 2. But here the last term is n minus 1. So put n minus 1 in place of n. Therefore, the formula becomes n minus 1 into n minus 1 plus 1 is n by 2. Therefore, the formula is n into n minus 1 divided by 2. Similarly, the next formula, sum of squares of n natural numbers we have studied. But here the last term is n minus 1 the whole square. Therefore, the formula becomes n into n minus 1 into 2n minus 1 divided by 6. In the formula, you will have minus sign. Up to n terms formula is n into n plus 1 into 2n plus 1 by 6. But here we have up to n minus 1 terms. Now the third formula, 1 cube plus 2 cube plus etc. up to n minus 1 the whole cube. The formula is n into n minus 1 by 2 the whole square. And sum up to n terms of a GP we know. We will use this formula when we have exponential function in limit of sums questions. So we know that a plus ar square, etc. The last term will have r power n minus 1. So the formula is a times r power n minus 1 divided by r minus 1. So if we have 1 plus e power mh, e power 2 mh plus etc. e power m n minus 1 times h. The formula will be 1 into the first term is 1. We get e power mhn minus 1 divided by e power mh minus 1. So these are the formulae which we are going to use in limit of sums questions. Write down in the formula notebook and memorize these formulae. Let us start exercise 7.8. It's a very small exercise. You may get limit of sums question for 4 marks or for 6 marks. First question, integral a to b x dx. Here the lower limit is a, upper limit is b. Our first step is writing the formula. Limit h tending to 0 of h times f of a plus f of a plus h, etc. f of a plus n minus 1 times h, where nh is b minus a. Second step is substitute for a and b. But in this question, they are a and b. Now third step is, let us find the expressions of f of a. F of a is, f of x is x. Therefore, f of a will be, this is our third step, finding these terms. F of a will be a. Then f of a plus h is a plus h, etc. f of a plus n minus 1 times h will be a plus n minus 1 h. Now we are going to add all these expressions and substitute in the formula. Therefore, integral a to b x dx is equal to limit h tending to 0 of h times. When we add these expressions, let us add the like terms and write. Let us first add all the constant terms. We have constant term a in all these expressions. So we have n terms. It becomes n times a plus. Now let us add h terms. So we have h. The next term will have 2h, etc. The last term has n minus 1h. So let us take h common. We get 1 plus 2 plus 3, etc. up to n minus 1 equal to limit h tending to 0 of h times na plus. Let us use sequences and series formulae. We know the formula for 1 plus 2 plus up to n minus 1. The formula is n into n minus 1 divided by 2. I told you the limit of sums questions can be done keeping the limit as h tending to 0 or n tending to infinity. Let us do with h tending to 0. Limit h tending to 0 of, I am opening the brackets. Let us distribute this h. It becomes a times nh plus half into nh into, I wrote nh. This h I am distributing it here. So it becomes nh minus h. Now we know that nh is a constant. nh is b minus a, which will be a constant. Let us substitute. Limit h tending to 0 of a times nh is b minus a. Wherever you have nh, plug in b minus a minus h. Now apply the limit value. H as 0. So A times B minus A plus half B minus A. H is 0. So this term also becomes B minus A. B minus A is common. Let us take it out. We get A plus B minus A divided by 2. Take LCM and simplify. 2A minus A becomes A plus B divided by 2. Therefore, the answer is B square minus A square divided by 2. Question 2. Integral 0 to 5x plus 1 dx. First step is writing the formula. Limit h tending to 0 of h times f of a plus f of a plus h plus etc. f of a plus n minus 1 times h, comma, nh is b minus a. Next, second step is substituting the values of a and b. Don't carry out the calculations with the letters a and b. Substitute. A is 0 in this case, b is 5, and f of x is x plus 1, the given function. Limit h tending to 0 of h into a is 0, so f of 0 plus h is f of h, etc. f of 0 plus n minus 1, h becomes n minus 1 times h, where nh is b minus a, 5 minus 0, which is 5. Third step, find these expressions. Let us find f of 0. f of x is x plus 1. f of 0 will be 0 plus 1, which is 1. Second term, f of h plus 1. Next term will be f of 2h, which will be 2h plus 1, etc. Last term is n minus 1 times h, which is n minus 1 h plus 1. We have to add all these expressions and substitute in the formula. Therefore, the given integral becomes limit h tending to 0 of h times. We have to add all these expressions. Let us add the like terms and write. Let us add h terms. We don't have h in the first term. We have h, 2h, etc. n minus 1 h. H will be common. Take h out. We get 1 plus 2 plus etc. up to n minus 1. You should know that when you take h term out, there may be a coefficient for h, but inside this bracket you will get 1 plus 2 plus up to n minus 1. Whereas if you take h square common with some coefficient outside, you will get 1 square, 2 square, etc. up to n minus 1 the whole square. Similarly, if you take h cube term, you will get 1 cube. There may be some coefficient here. You will get 1 cube plus 2 cube, etc. up to n minus 1 the whole cube. For h cube, you will get cube terms. For h square, you will get square terms. For h, you will get 1 plus 2 plus, etc. Now let us add all the constant terms. The constant terms are 1. How many constant terms are there? N times we have. See, h is not there in the first one. That's why we had only n minus 1 terms. But the constant term 1 is in all n terms we have. So it becomes 1 plus n times, which is n. Now the next step is using sequences and series formulae. We know the formula for this, which is n into n minus 1 divided by 2. Now the next step is distributing this h. So the first term becomes nh minus h. By mistake, don't write nh minus 1. You are multiplying by h. 1 nh is this. The other h I am distributing it here. That's how I got nh minus h, and we have by 2, and the second term nh, because h is common for that also. Now we know that nh is a constant, which is 5. Let us plug in the value of nh. 5 minus h divided by 2 plus 5. Now apply the limit value. H as 0. So 5 5s are 25 by 2 plus 5. 2 is the LCM. 25 plus 10 is 35. The answer is 35 divided by 2. Third question. Integral 2 to 3 x square dx. First step, writing the formula. Limit h tending to 0 of h times f of a plus f of a plus h, etc. The last term is a plus n minus 1 times h, where nh is b minus a. Next step is substituting the values of a and b. In this question, a is 2, the lower limit, b is the upper limit, which is 3, and the expression given is x square. So let us substitute for a and b. Limit h tending to 0 of h times f of 2 plus f of 2 plus h, etc. f of 2 plus n minus 1 times h. Okay, let us calculate nh value. nh is b minus a, which is 3 minus 2, 1. Now next step is finding these expressions. F of 2. F of x is x square. F of 2 will be 2 square. Then f of 2 plus h will be 2 plus h the whole square, etc. The last term 2 plus n minus 1 times h, which is equal to 2 plus n minus 1 h the whole square. Open the brackets and simplify. 4 plus 4h plus h square. Here also let us open the brackets and simplify, but don't open the brackets of n minus 1. Other brackets, the whole square bracket, you open and simplify. So 4 plus 2 2s are 4 times n minus 1 h plus b square, term is n minus 1 square and h square. Now we have to add all these expressions and substitute in the formula. Therefore, the given integral is equal to limit h tending to 0 of h into, let us add the like terms. The first term, I am adding 4, the constant term. We have 4 plus n times, so 4n plus, let us add h terms. 4h, 4 times n minus 1h. 4 is a common coefficient, so 4h is common. We get 1 plus 2 plus etc. n minus 1. I told you when we take h common, we will get 1 plus 2 plus etc. n minus 1. Now let us add h square terms. H square, and here we have n minus 1 square, h square. Let us take h square common. We get 1 square, 2 square, etc. up to n minus 1 the whole square. Next step is using series formulae. 4h into, this sum will be n into n minus 1 divided by 2 plus h square times sum of these numbers will be n into n minus 1 into 2n minus 1 divided by 6. limit h tending to 0 of, as I said, you may do the question with limit h tending to 0, or you may change it in terms of n and do. I'm keeping it in terms of h. So let us distribute this h. 4nh plus 2 times nh, and this h let us multiply with n minus 1. So it becomes nh minus h plus 1 by 6 times nh. One h I wrote it with this. The other h let me distribute here and write. And outside one h is there. I will write it with this term. So it is 2nh minus h. We know that nh is a constant which is 1. Let us substitute the value of nh as 1. And substitute the limit value h as 0. Therefore, the answer is 4 plus 1 minus 0 into 2 plus 1 by 6 times 1 minus 0 is 1, 2 minus 0 is 2. Therefore, the answer is 6 plus 1 by 3. Take LCM 3, 18 plus 1, 19. The answer is 19 divided by 3. Question number 4. Integral 1 to 4 x square minus x dx. First step, writing the formula. Limit h tending to 0 of h times f of a plus f of a plus h plus etc. f of a plus n minus 1 times h, where nh is b minus a. Second step, substituting the values for a and b. A is the lower limit 1, b is the upper limit 4, and the expression given is x square minus x. Limit h tending to 0 of h times a is 1. So f of 1 plus f of 1 plus h plus etc. f of 1 plus n minus 1 times h. And nh is, calculate b minus a, 4 minus 1, 3. Now the next step is, we will find these expressions. F of 1. F of x is x square minus x. So f of 1 will be 1 square minus 1, 0. Next, f of 1 plus h, which is 1 plus h the whole square minus of 1 plus h. I told you to open these brackets and simplify. 1 plus 2h plus h square minus 1 minus h. Let us simplify this. It becomes h plus h square, etc. Let us calculate the last term, which is f of 1 plus n minus 1 times h. 1 plus n minus 1 h the whole square minus 1 plus n minus 1 times h. I told you to open the brackets and simplify, but don't open the brackets of n minus 1. Other brackets you simplify. A square term, 2ab term plus b square term. Distribute this negative sign. We get this expression. Let us simplify. N minus 1 h plus n minus 1 the whole square h square. We have to add these expressions and substitute in the formula. Therefore, integral 1 to 4 x square minus x dx is equal to limit h tending to 0 of h times. Let us add h terms. Nothing is there in the first term, 0 it is. So h terms, this and this. Let us take h common. We get 1 plus 2 from the next expression, 3 from the next expression, and up to n minus 1. Then we have h square common. Look at the second terms. Take h square common, we get 1 square, 2 square, 3 square, up to n minus 1 the whole square. Now we will use formulae for the summation. Limit h tending to 0 of h times h into, this total is n into n minus 1 divided by 2 plus h square times, and this total is n into n minus 1 into 2n minus 1 divided by 6 equal to limit h tending to 0 of, let us distribute this h, nh, this nh, this h I am going to distribute with this nh minus h but divided by 2. By mistake don't write nh minus 1, the answer will go wrong. nh, the other h, let us multiply the second bracket, and this h let us multiply with the third bracket, 2nh minus h divided by 6. nh is a constant which is 3. Let us substitute nh as 3. 3 times 3 minus h by 2 plus 1 by 6 times 3 times 3 minus h times 2 3s are 6 minus h. Now apply the limit value h as 0. So the first term becomes 9 by 2. The second term is half multiplied with 3 and 6. Nine divided by 2 plus 9. LCM is 2. We get 9 plus 18. The answer is 27 divided by 2. Let's do question number 5. It has exponential function, integral minus 1 to 1 e power x dx. Let us write the formula. Limit h tending to 0 of h times f of a plus f of a plus h, etc. plus f of a plus n minus 1 times h, where nh is b minus a. This is the formula. Second step, substitute the values of a and b. A is the lower limit, which is minus 1. B is the upper limit, which is plus 1. Therefore, it becomes limit h tending to 0 of h times f of minus 1 plus f of minus 1 plus h, etc. f of minus 1 plus n minus 1 times h, where nh is equal to b minus a. 1 minus of minus 1, 1 plus 1, it becomes 2. nh value is 2, which is a constant. Now we will find these expressions. That is our third step. F of minus 1. F of x is e power x. So f of minus 1 will be e power minus 1. Then f of minus 1 plus h, which is e power minus 1 plus h. I can separate this as e power minus 1 times e power h plus etc. The last term is equal to e raised to minus 1 plus n minus 1 times h, which can be written as e raised to minus 1 times e raised to n minus 1 h. Now we have to add all these expressions and substitute in the formula. Therefore, the given integral is equal to limit h tending to 0 of h times. Let us add all these things. We have e power minus 1 common. So e power minus 1 times, we get 1 from the first expression plus e power h from the second expression plus etc. e power n minus 1 times h from the last expression. And this is a GP. If you have exponential function, this comes as a GP. And we know sum up to n terms of a GP. The formula is a times r power n minus 1 divided by r minus 1, where a is the first term, r is the common ratio. We get limit h tending to 0 of h e power minus 1. E power minus 1 is a constant. It can be removed outside the limit. Now let us use the formula. A is 1. R. To find r, you can do second term divided by the first term. E power h divided by 1 is e power h. And power n minus 1 divided by e power h minus 1. E power minus 1, a constant. Take it outside the limit. E power nh. We know the value of nh. Nh is 2 minus 1 divided by e raised to h minus 1 divided by h. H was here. I have taken it to the denominator. Write the reciprocal of the denominator and check. We get h back here in the numerator. So I have written this h in the denominator. Now I can apply the limits. This is 1 by e. E square minus 1 is also a constant. Now apply the limits. Limit h tending to 0 of e power h minus 1 divided by h is 1. We know this formula. Therefore, the answer becomes 1 by 1. Let us distribute. We get e minus 1 by e. Question 6. Integral 0 to 4 x plus e power 2x dx. First step is writing the formula. Limit h tending to 0 of h into f of a plus f of a plus h plus etc. f of a plus n minus 1 times h, where nh is b minus a. Second step is substituting the values of a and b. Therefore, we get limit h tending to 0 of h into f of a is 0. b is the upper limit, which is 4. We get f of 0 plus f of 0 plus h is h, etc. f of 0 plus n minus 1 times h. Don't carry out the calculations with a and b. Substitute the value of a. If the lower limit is 0, the expressions are easy to calculate, where nh is equal to 4 minus 0, which is 4. The third step is we find these expressions. F of 0. F of 0 is f of x is x plus e power 2x. Therefore, f of 0 will be 0 plus e power 0. E power 0 is 1. It is not 0. And then the second expression, we have to find f of h. F of h will be h plus e power 2h, etc. F of n minus 1 times h will be n minus 1 h plus e power 2 times n minus 1 h. We have to add these expressions. Therefore, the given integral is equal to limit h tending to 0 of h into, let us add all the h terms. We don't have h term in the first expression, in the second and the last one. If we take h common, we get 1 plus 2 plus 3 plus etc. The last term will have n minus 1. I have told you if you take h out, you will get 1 plus 2 plus etc. If you take h square out, you will get square terms, 1 square, 2 square, etc. Then, let us add e terms. The first expression has 1 plus the second one has e power 2h, etc. The last term is e power 2 times n minus 1 h. And this is a GP. Sum up to n terms of a GP is a into r power n minus 1 by r minus 1, where a is the first term and r is the common ratio. Limit h tending to 0 of h into, let us use the formula for this series, which is n into n minus 1 divided by 2. And here the first term is 1. The common ratio. To find the common ratio, divide the second term by the first term. So e power 2h divided by 1 is e power 2h. This is r power n, so whole power n, minus 1 divided by r is e power 2h and minus 1, equal to limit h tending to 0 of, let us distribute this h, this nh, and distribute this h and write. So nh minus h divided by 2 plus e power 2 nh minus 1 divided by e power 2h minus 1 and into h. nh is a constant. Let us substitute the value of nh. Therefore, limit h tending to 0 of nh is 4. 4 minus h divided by 2 plus h times e power 2 times 4 is 8. E raised to 8 minus 1 divided by e power 2h minus 1. Let me write this h here in the denominator. Limit h tending to 0 of two times 4 minus h. E power 8 minus 1 is a constant, divided by e power 2h minus 1 by h. To apply this formula of limit x tending to 0 of e raised to x minus 1 divided by x is equal to 1, we need 2 here. So let us multiply by 2. Therefore, this term becomes 1 by this limit formula. Let us apply the limit. So 2 times 4 minus 0 plus e power 8 minus 1 is a constant divided by this limit formula, this becomes 1. As h tends to 0, 2h also tends to 0. So we can apply that formula. It becomes 8 plus e raised to 8 minus 1 divided by 2. 2 is the LCM. 16 plus e raised to 8 minus 1, which is 15 plus e raised to 8 by